Hi everybody, and welcome to another Sun Space Industry webinar. Hi, I'm Charlie from the University of Bristol.
So I'm Ian Raper. I'm one of the co-chairs of the Space Universities Network. We're very pleased to be hosting another webinar from the Space Universities Network. So just a very brief explanation of what the Space Universities Network is. And basically we're a large group of UK-based universities who have come together with a common passion for teaching within subjects within the space science and engineering. So we now have nearly 100 individual members from universities across the UK, and we come together to share resources and teaching ideas. So this is kind of the breadth of what the network is doing. The network is for academic staff rather than students, but students benefit from us having this network because it's allowing us to share these best practices and new ideas of subjects to teach within the space sector. So this is our website. There are some aspects on here, if you go to the Space Universities Network website, that anyone can look at, and there are some bits that are there for academics only. But through this, we are trying to improve our own teaching and learning skills and subject knowledge so that we can then pass that on to students. And these webinars are part of those resources that we are developing. And we've had now quite a long, successful run of these webinars to share the very broad range of topics that fit within the space sector and space teaching. So with that, I will hand back to Charlie to introduce our speaker for this evening, and I hope you enjoy this webinar.
Cool. Thank you, Ian. So today we're very lucky to have Ali here. She is the business manager for defense space at Frazer-Nash Consulting, leading on strategy, business development, and client relationships across space, defense, government, and industry. Prior to this, she was a research fellow at Space Policy and Security in the Military Sciences team in the Royal United Services Institute for Defence and Security Studies, where she remains an associate fellow. Ali's expertise cover international space policy, military space programs, space warfare, counterspace capabilities, space situational awareness, arms control, and the intersection between space and missile defence. She has written for a variety of publications, regularly provided expert commentary to the media, is frequently a speaker at international conferences, and has acted in an advisory capacity for both the UK and US governments. This talk will focus on space sustainability. What is it? How do we do it? And why is it important? It covers space situational awareness, and it is used in civil and military context. The relationship between sustainability with space safety and security, the effort of the international community to develop mechanisms to ensure the future use of space. So this talk will be about 30 minutes, and then we'll open up to questions from you guys. So please do post them in the chat as we go along. Also, just so you know, this whole session will be recorded, and that will include the chat as well. Cool. So now I'll hand over to Ali to start sharing her screen and begin the talk.
Brilliant. Thank you so much. Let me get my screen shared here. Brilliant. So yeah, thank you so much for the opportunity to speak to all of you. So I'm going to cover all these aspects of space sustainability. I think I just want to be clear, because sometimes there's a bit of confusion, because you can have space sustainability and then you can have sustainability from space. So I'm very much focusing on the sustainability in space, and that is orbital sustainability. So space sustainability, when we think about the orbits that we use, particularly low Earth orbit, but also out to medium Earth orbit and GEO, there's a lot of concern about the amount of objects we have out there, and to ensure that we have the use of these going forward. So space sustainability is about that sustainable long-term use of orbit and everything that we can do to prevent the worst case scenario. The worst case scenario is something called the Kessler syndrome. A man called John Kessler at NASA came up with, where old satellites, pieces of debris just kind of create a chain reaction, and we end up with an unusable environment. We obviously don't want to end up there. We use space for everything, everything from disaster response, GPS, communications. So we have a huge amount to lose. It's become a huge topic recently, number of reasons. I think, we see these mega constellations for companies like SpaceX, talking about 20, 40,000 satellites in these constellations. We've seen an increase in the testing of some counterspace capabilities like kinetic anti-satellite missiles that are creating debris. We recently saw, not that long ago, the International Space Station having to take some maneuvers to avoid pieces of debris. So we're starting to see a lot more now that rather than being something quite niche and something not everyone should be worried about, this is now understood to be a globally important topic and something that can affect everyone. And what we've seen as well is looking at the parallels then between the potential sort of crisis in the space environment to the crises we're seeing in terrestrial environments. So things like climate security, climate change, plastics in the ocean, for example. And some of those parallels are quite political. The problems have been caused by a small number of actors. The majority of the debris that exists up there, comes from just a few states, primarily the US, Russia, for example, China. But it's often the smaller states are the ones who will be most affected. No one knows who should pay for it, who should manage it. And so when we look at space sustainability, we have to understand it within the context of just global politics, the interplay between different states, the commercial sector, different allegiances, and how what we see happening on the ground is going to be paralleled what's happening in space. We can't just treat space as being different in this sense. So is it the next environmental crisis? Well, I think, a lot of people would argue it is, and it needs to continue to gain a lot more attention. A little bit of a brief history of space debris. So the first launch into orbit of an object in 1957 was Sputnik. Sputnik separated from its launch vehicle, and it also lost the nose cone. So we ended up really then with 2 pieces of space debris to 1 functioning satellite. So it wasn't really a great start. And of course, once Sputnik stopped transmitting and basically became an object up there, we were even in a worse situation where we had 3 pieces of space debris and no functioning satellites. Of course, back then, no one knew how many satellites would be in orbit and how crowded it was going to get and how much we would rely on space. So the thoughts about collisions, space debris, really wasn't there. But obviously, time has gone on. The uses of space have increased, the number of actors have increased, and so there's always a danger now. So again, what's happened in the years since? Massive increase in the number of satellites. 2009 actually saw an Iridium satellite collide with a no longer functioning Cosmos satellite, created a massive amount of debris. I mentioned anti-satellite ASAT tests. In 2008, China tested an anti-satellite missile against one of its old weather satellites. This was at an altitude, I think, just over 800 kilometers. It produced well over 2,000 pieces of debris. And many of those pieces are going to remain in orbit for many, many years. 2018-19, we saw India test an ASAT. This was in a much lower orbit, just under 300 kilometers. And so there was an argument that, oh, this is okay because the debris isn't going to be as long-lived. So trying to almost say this is a responsible ASAT test. Of course, can't really have a responsible ASAT test, but again, lots of debris tested from that, that was created from that. And as I mentioned, a recent Russian test. So increase in that has led to an environment that is very, very different to even what we had 10 or 20 years ago. So now we're in a situation where if you look at the European Space Agency's figures, there are more than 170 million pieces of objects in orbit that are over 1 millimeter. Of that, we're only talking about 5,000 active satellites. Most of that is old satellites, pieces of rocket bodies, pieces of debris. We know from orbital physics, things are moving pretty fast. We've seen flecks of paint cause damage to the space shuttle. So even an incredibly small piece can cause a satellite, to stop functioning, or could create more breakups. So we're in a really, really difficult position now to say, okay, how are we going to detect all this? How are we going to track it? And how can we make sure that we can, how are we going to turn this around? How can we ensure that we don't just keep going down a path towards a Kessler syndrome, towards a scenario where we can't use space anymore? So we have all these terms for these activities, and the difficulty with a lot of these definitions is that there isn't really an agreement on what they mean. You'll again, if you look at what European Space Agency versus NASA versus UK Space Agency versus militaries will say, they are slightly different. But this is sort of my understanding of what they mean and who's responsible for them. The space situational awareness is an overarching term for our understanding of the space environment. So that includes the detection and tracking of objects in orbit, whether that's satellites, whether that's pieces of debris. But it also includes things like understanding space weather, so the activities of the sun and what impact that has on the orbital environment. And also things like near-Earth objects, so asteroids, micrometeoroids coming through, and what damage they could have, they could play. So space situational awareness as an activity was traditionally carried out by militaries, particularly the United States, but it has slowly sort of transformed into a sort of dual-use military and civilian activity. And we're now seeing, I'll come on to a bit later, but we're now seeing a move away from a purely military activity. Within space situational awareness, we have something called space traffic management. So that's sort of forgetting some of the space weather, the near-Earth objects, and really focusing on how are we managing all of these? How are we ensuring that satellite operators know where their satellites are able to communicate with each other, which is incredibly important. Just to give you a couple of examples of why that's important, two that I know of, where satellite operators were given warnings of potential conjunctions. So, your satellite might come into very close proximity with another satellite. Someone might have to move. I have heard of companies having to Google the contact details of the other company in order to get in touch with them. I've also heard that ESA was trying to send emails to SpaceX and got no response. And it's sort of being left now to individuals. So there's a lot of talk about trying to set up some sort of international space traffic management system to ensure that everyone has access to the right data, everyone's able to talk to each other, and that there is some sort of centralized system for ensuring that where satellites are and what they're doing is understood to try and avoid, potentially in this case, just trying to avoid accidents. The term that has really sort of increased use we've seen in the last couple of years is space domain awareness. And this is really something we're seeing much more from a military perspective. This is really the military version of space situational awareness. And what this is including is things around understanding not just where objects are, but what they're doing and why they might be doing it. So militaries will be much more concerned. So, for example, of a satellite that with maneuvering capabilities, it's going to start getting a bit close to your satellite. It's not behaving in a way that we would necessarily expect. What is it doing? Are they trying to interfere? Are they trying to disrupt our satellites? And so militaries, and there's quite a bit of work that militaries and civilian activities authorities will do together. But there is that really core military activity around the intelligence side of it, which is what space domain awareness is. That is my understanding of it. As I said, others may disagree. I've seen the UK Space Agency use the term space domain awareness rather than space situational awareness. So again, some confusion. In essence, they're all trying to keep the space environment fairly safe, sustainable, and with an element of understanding of what is happening up there. You often come across what I call the 3 S's because they're all interlinked, and that's sustainability, safety, and security. So I've mentioned sustainability. That's, you know, long-term use of space. Space safety is ensuring the safe, it's quite simple, the safety of objects in space. So particularly if you look at things like the International Space Station or civilian satellites, particularly when we start to see mega constellations, more and more satellites, but also ideas around in-orbit manufacturing, in-orbit servicing. So lots of satellites that might you know, come together. We're seeing these maneuvering capabilities, and there's a lot of confusion about that, and a lot of concern about, you know, if something goes wrong. Example of why safety might be important. I know my colleague James Cornish has spoken to this network before about space-based solar power, where you're talking about robotically assembling thousands of modules in space. So safety is a huge aspect of that. And obviously safety and sustainability, therefore, there's quite a lot of overlap. Security is, again, much more focused on military assets in space, the dual use assets, so civilian satellites that might support space operations. So for example, Starlink satellites, other communication satellites, and ensuring that those are protected, that we can defend against potential counterspace activities of adversaries, ensuring command and control in space, that our satellites can do what they need, and also potentially being able to affect our adversaries. And again, quite a few links there with safety, sustainability, with safety and sustainability. So these are all activities that impact on each other and do rely on each other to an extent. You can't have long-term space security if you don't have sustainability. You can't have the long-term support to military operations from space unless you have sustainability. But sustainability also can't exist without security, without ensuring that we don't see a kinetic conflict in space, quite simply. So whilst countries are testing kinetic anti-satellite missiles, no one wants to see that sort of conflict in space, because the repercussions could mean that no one could use it. So it's a no-win situation for everyone. So security is focused, as I said, on military assets and protecting the use of space for that. And I think what's interesting is who's responsible for all of these, and where the push and pull is. So again, I want to make the parallel to what we see happening on the ground. So climate security is very important, but when you have a conflict in Ukraine, that sort of becomes the primary focus of everyone. And I think that the efforts towards space sustainability will always, in some way, kind of come second to those for security. So the needs of security actors in space will probably always trump sustainability. That's not to say that they can't play a role in sustainability, but I've seen at times a little bit too much focus on militaries as being those responsible for sustainability in space, and I think it's very important to not have them be the single sort of the responsible actors who have responsibility for bringing that together. Sustainability really needs to be a civil activity that works with militaries to take it through. So I said it's very important that when we think about sustainability, we understand how it interacts with and affects and is affected by both safety and security in orbit. So we have this problem. We have this issue of lots of things happening, lots of satellites, more and more actors, cheaper launch, and this potential that things could just kind of get out of control if they aren't already. And there are some who would perhaps say that. So how do we solve that? How are we actually going to achieve sustainability in space? So on one aspect, we have technical solutions. So we have more data providers. So this is more and more actors who are actually gathering data on what is happening in space. This may be through radar, through optical telescopes, detecting objects, trying to track objects, having databases of where they are, and being able to provide some sort of picture. But one of those problems with more and more data is not just the interpretation of the data, but the interoperability of the data. How can we ensure that what I'm getting from one provider is useful and can be used alongside what I'm getting from another provider? This is particularly important. I'm going to quote here someone called Mariba Jar from the University of Texas at Austin, very good friend of mine and one of the world's leaders in this area. And he will say, if you have a satellite and I'm going to tell you where that satellite is, that's my opinion of where the satellite is based on the information I have. It's not fact because it might differ from someone else. This activity isn't perfect. There are errors involved, and that could be tens, maybe hundreds of kilometers. So when you're talking about satellites, potentially colliding, we need to know what's happening, and so we need multiple sources to be able to corroborate where something is. So we need to ensure that we can use those multiple sources. This is also really important in security. If my satellite stops functioning and I'm trying to find out why, and I think, oh, there's an adversarial satellite that was sort of nearby doing something a bit weird. If I'm going to blame someone, if I'm going to attribute that activity to someone else and potentially respond, I need to be pretty sure. So I need multiple sources of data. Global coverage, again, just need to make sure that we can see everything. So, not just looking, in one part of the sky, making sure that all those data providers are positioning their assets all around the world. Better scientific understanding. Again, this is just to ensure that all those different factors that can affect how a satellite or piece of debris is moving are understood. So again, to quote Mariba, just because I can detect something doesn't mean I can track it. I can detect a satellite that's functioning and I've got a pretty good idea of where it's going to be. But if I'm detecting a particularly large piece of debris, what is the effect of solar radiation pressure on that based on what is it made of? How big is it? What's the surface area? Is it tumbling? Don't know. Is there some sort of internal pressure from internal radiation? So there's a lot more going on than just saying here's an object and where is it going to be. Again, we can't treat all these objects as sort of just nice tennis ball shape, simple balls made of the same material. So we need to be able to understand a lot more what's happening there. And again, come back to something like space weather, understanding solar activity and how that impacts on orbits, and what that radiation pressure means, and how it might affect how satellites are moving. And then in terms of what we can actually do in orbit, things like debris removal, some really interesting experiments have been carried out looking at different ways of removing pieces of debris. Nets, harpoons. I have seen some slightly bizarre ideas about very long pieces of sticky tape almost that would go and sweep up debris. We need to figure out how we can make that work to ensure that any activities are only getting rid of old satellites or debris and not functioning satellites. And also, how do we make that sort of cost effective? Because yes, removing one satellite is great, but what really huge impact is that going to have on the environment? So ensuring that any interventions made are made sort of quite strategically. Again, looking at that play there between sort of sustainability and security, lots of concern from the security community about that capability. You know, if you can remove a piece of debris, you can remove a functioning satellite. So again, understanding the potential threat of satellites with that capability. In orbit servicing, so rather than letting a satellite just reach the end of its life and become a piece of debris, can we fix it? Can we ensure that it lasts longer? So again, you know, lots of people working on how to do that. Again, a slight security, you know, question. If you can fix it, you can break it. So we need to understand that. And so, you know, on top of that, we've got mission extension vehicles. Last year, Northrop Grumman did actually show the capability of a satellite basically being able to dock with another one to extend its life for a significant period of time. So there's lots going on, lots of innovation, lots of really great new ideas about how to, you know, how we can kind of fix some of this problem, but also some questions. How can we make it work really well, and how can we ensure that by doing this we're not creating some sort of security situation? And then alongside the technical solutions, of course, we've got the political solutions. So those are three friends of mine from the sort of space sustainability community who've been involved in quite a lot of these talks. So we have the IADC space debris mitigation guidelines. So for example, you know, there's a guideline on, I think it's called the 25-year rule. So you need to ensure that within 25 years, you've deorbited a satellite after the end of its life. I think most would agree that's probably too long. But lots of guidelines coming through, and just how can you ensure that, you know, particularly now, every new mission that's going up, let's make sure that we're not adding to the debris. Let's make sure we've got in place those activities for the end of for end of life. So whether that's, you know, deorbiting, if you're in LEO, if you're in GEO, moving out to your graveyard orbit. The UN First Committee has been going through talks over the last couple of years on space security and the open-ended working group on space security. And again, this is not to create sort of international treaties, but it's about guidelines, it's about behaviors. So really looking at what they're calling responsible behavior in space. Its focus is more on the security side than sustainability side, but I think sustainability is sort of the nice byproduct of these conversations that are going on. Perhaps the most positive thing that's come out of that is the United States actually coming out and saying we are going to ban the testing of kinetic anti-satellite missiles. We're not going to do that anymore. And that's been supported by quite a few other states now. And that's probably not something that even 2 years ago we thought was possible. So we've seen really, really big strides in this area about saying it's not about the technology, it's not about the capability. So when we think about things like debris removal that, you know, have those positive benefits but could be used in a not so good way, we're not thinking about, you know, do we need to regulate technology, but we're looking at if not at this stage regulating, at least promoting good behavior, promoting positive behavior, to try and make sure that everyone's saying, yes, I'm going to do the best I can to ensure that we're not creating these long-term problems in space. Really important part of all that is national licensing and regulations. These differ greatly internationally. You may, you know, see that Rwanda has a space agency through which it licenses space activities. It doesn't really have a huge space program itself. There's concern about what we call forum shopping. So companies actually going to countries that they see as having sort of lighter regulations, but a push through these responsible behaviors to ensure that if you are trying to get your mission licensed through a national body that, you know, some of these regulations sort of built in, some of these recommendations are built in. The insurance industry is going to play quite a big role here. Something that we've seen people talking about is almost like a space environmental footprint. So part of that, getting your insurance, if you want lower premiums on your space mission, ensure that you have the maximum sort of protection against something going wrong. So again, you know, what are you doing to mitigate, you know, the potential creation of debris? And finally, the political, really building on the Outer Space Treaty. There is a clause in the Outer Space Treaty that's sort of an environmental clause, and being able to use those parts of it that sort of promote space sort of for humankind and for good things, to again try and say, you know, we want to keep using this. This is really important for us as a planet, as a species. Let's not mess it up the way that you know, you can argue we've messed up a lot of parts on Earth. So what can we use out of the Outer Space Treaty to kind of keep promoting sustainability? So that's sort of what we're doing. Where are we going to go in the future? I do think that at the moment, the political solutions are going to be limited. It said their guidelines are voluntary. It's not easy to get international agreement on anything these days. Again, you know, look at still nuclear weapons, look at climate security. I think it'd be quite naive to suggest that we can get somewhere. The treaties that we have seen tried to get through the UN on preventing an arms race in outer space and the prevention of the placement of weapons in orbit treaty have stalled. The US, Russia, China won't work together on these. So it really is going to start with this responsible behavior and more actors just kind of getting involved in that, so that we see those who aren't behaving responsibly as being sort of outcasts in this area. We are seeing more civil government departments, I think I mentioned earlier, take on space situational awareness activities. So a lot of those activities have moved out of the US Department of Defense into the US Department of Commerce. And I think that through that, it kind of gets a bit more visibility across governments, but just across people as well. And I think that with that gaining a lot more visibility, more and more people start to get interested in it and say, wait, hang on, you know, I don't like this idea of space not being there anymore. You know, whether it's because you want it for scientific purposes and you like, you know, the pictures from telescopes, or because you recognize that without it, you know, our way of life is very different. You know, hopefully that can get some momentum going, and just a bit more push from governments to try and get some of these agreements. There are risks. You know, we look at these mega constellations, we look at what's happening there. That it can be quite scary when we see the number of satellites that are going up when we don't have all these mechanisms in place. So it's not just states, but it's also the private sector that really needs to be involved in this to understand their responsibility. And I mentioned the proliferation of counterspace capabilities. I mentioned kinetic anti-satellite missiles. There are many other capabilities that we see. There's interference. There's damage you can cause that's not kinetic. So the satellite might still be intact, but it might not work. Becomes a piece of debris. So the ever-changing security environment in space is always going to be a bit of a risk for sustainability. No one really knows how close we are to triggering the Kessler syndrome, whether we've already reached that point or not. We may be somewhere off, but even if we are, there's still a huge amount of work to do, and it's everyone who has an interest in space and who works in space, who's involved in it, does have that responsibility. The same way, I suppose, with something like cyber. You know, we all get the updates. for our, you know, our laptop security, our phone security. You know, we all avoid phishing emails. So it's the same thing here on space. Every actor needs to be aware of what they can do to ensure that we can still use space basically forever. So I think I will finish there, but I'm really happy to answer any questions on anything I've spoken about tonight, or just more generally about space, about careers in space, and working in what's a really exciting area. Yeah.
Cool. Thank you very much, Ali. That was a really, really great presentation. So question from Gio and a few others in a similar ballpark. So maybe how are different countries changing the rules in space, such as Russia, China, and the US? And also, if you can maybe touch on, say, mega constellations as well, and how that's changing space.
How they're changing the rules in space. I mean, one answer is that there aren't any rules in space to be changed.
It may be challenging.
Sorry, how are they?
It may be challenging the rules in space, or changing.
I think, I mean, the rule, you know, I don't really see them challenging the rules we have. I think what I really see them more as challenging, I suppose, the efforts to establish new rules. So as I said, it's not so much just about where, you know, we do have rules in space, and for the most part, you know, everyone kind of abides by them. But when we start thinking about the future, actually what we want to do is ensure that, you know, we have you know, some sort of agreement on how close, you know, a satellite can get to another one before, you know, that the satellite can say, hey, you're getting too close to me, if they're, you know, if you haven't had a previous conversation about this and about these behaviors. And I think it's the lack of support from certain states that is just making that more difficult. So that sort of intransigence, and again, I want to come back to that point of it's really no different to what we're seeing certain states do in other areas, you know, whether that's on climate, whether that's on other areas of disarmament. I actually think, to come to the point of mega constellations, the bigger impact on the rules is coming from the private sector. So as an example, particularly at the moment, and it is changing, because we are seeing states, we are seeing military sort of embrace constellations of satellites rather than sort of exquisite platforms. But if you kind of take it as a sort of simplified view of, militaries have a small number of sort of big important satellites. The loss of one of those is going to have a really big impact. SpaceX has X thousand satellites. If one of those goes wrong, it doesn't really matter, right? They just go, it's fine. We don't, it doesn't affect us in any way. And it happens all the time. You know, they launched a number of satellites, and there had been some solar activity, and those satellites didn't actually reach orbit. And it's okay. The company still goes, the constellation still works. We are seeing militaries move into that way of thinking for some capabilities, in terms of, let's have more satellites, we can have responsive launch, we can replace them. But in terms of just the volume of satellites, the number of launches, I think the bigger impact on whatever rules of the road we have for space are definitely coming from the private sector.
Nice, thank you. So the next question we have is from Alejandro, asking, are companies analyzing the impact that orbital debris, which is purposely re-entered into the atmosphere to get evaporated, has on the properties and composition of the atmosphere itself?
Not that I'm aware of, but it's a really good point. And again, I think, when you were talking about a few satellites, it may not have been an issue, but yeah, if you're thinking about potentially thousands of satellites being deorbited, that is something that needs to be considered. But as far as I'm aware, it's not something I've necessarily heard of. I'm not sure a company would do it. I would think it would probably become more from an NGO, who would probably be concerned with that. But whether they would have access to all the information, particularly on the makeup of the satellite, and then the ability to properly analyze what impact that would have on the atmosphere. Something that needs doing, and is definitely not getting the attention.
Nice. And so the next question is about the graveyard orbit and whether that's actually a good solution, or not.
In terms of geo, I think it's the best solution at the moment. But when we start to think about the future, we're going to see a lot more missions going back to the moon. We're potentially looking at asteroid mining, all these activities sort of happening beyond geo, and we might see more and more traffic kind of, I suppose, coming back and forth a little bit. So there could be some concern of more and more objects out in a graveyard orbit that you'd have to sort of go around. It's pretty big out there. I think potentially by the time we got to the stage where a graveyard orbit was crowded enough, I think we may have cracked the ability to recycle, reuse in space, manufacture in space. So I think what people are thinking about is, okay, well, if we've got that in geo, could we actually use it, but rather than just put it in a graveyard orbit? So at the moment, it's probably the best idea. I don't know if it would be a problem before we can do something else about it.
So the next question is from Ian Muirhead. He says,
hi Ian, I know you from Twitter.
The ongoing open-ended working group at the UN was recently partially derailed by Russia through. Maybe if you could see the question in the chat.
It is difficult, and I think that's why we always need to be aware that activities on the ground and the politics on the ground is always going to have an impact on our ability to actually reach agreements, and yeah, particularly around what's happened in Ukraine and what that's causing Russia to do, in terms of saying we're not going to support this. I do think we should continue down this route, though. Yes, it's good to have our partners, and yes, it's good to work with us, but you can have 99 out of 100 space actors behave well, and all you need is the one not to behave well. So you can't just rely on your friends and your allies. Despite what's happened at the UN and the lack of support for Russia, I still am more positive than I was because of the US-led sort of ban on ASAT testing. And the more we can just continue to support, promote those behaviors, the more we can continue to get other countries on board. Yeah, we might not ever get to a full treaty, but we need to continue engaging. I don't think kind of giving up is the right idea. That we need to keep talking to them, and I just try and remain hopeful, remain positive, that eventually we'll get some agreement, some movement on that.
Right. So the next question we have is from Ian Raper. Do the FCC have the power to really protect space sustainability through appropriate licensing, or will the financial power of Google, Amazon, Facebook, Apple, and SpaceX ultimately trump all the good intentions?
Yeah, yeah, money talks, doesn't it? I think that really is the biggest drive. One of the biggest drivers for all this is definitely the financial side of it and the money that can be made from space. I don't know if it's quite that binary, I guess. I think that, yeah, it is limited in what it can do in terms of licensing, and obviously, there's always going to be an economic pressure, to support these companies. They're not, but I don't want to tar all the companies or the private sector as sort of being irresponsible. There is a spectrum there. A lot of them are very involved in conversations around sustainability. They support, a lot of them have, are very supportive of the work that's going on in the UN and a lot of these forums. So I think it's important to bring them on board and have them as part of the conversation, and kind of give them that sense of belonging as important actors alongside states. And again, that just promotes the good behavior. So, yes, there's behavior for states, but there's behavior for the private sector. And I think, coming back to the point I made about this issue kind of gaining more traction amongst the public, like we see the impact that people can have on companies and saying, I don't want to support this company because it's got really bad environmental credentials. I don't want to support this company because I don't like its social values. It's promoting something I don't agree with. The backlash we've seen. So I think that, again, the more that the importance of space sustainability is understood by the general public, again, the more that organizations that care about this can kind of say, look, you've got a choice to use space-based internet from this company or this company, but this is the company that's doing really good things for space sustainability. And again, so actually being able to put the financial pressure kind of back on the companies, maybe one of the best ways of ensuring that they play nicely.
Cool. So the next question we have is from George, and it's, what would you like to see the next generation of engineers do to ensure sustainability?
I think just awareness, to be honest. I think that, particularly I go to a lot of events, a lot of sort of big industry events and expos and conferences, and one thing you see a lot happening, particularly conversations that are directed towards startups, SMEs, look, there are so many opportunities in space. Come work in the space sector. It's going to be brilliant. You can grow your company. You can do really exciting things. A lot of the times, that message isn't complemented by the messages around security and sustainability, about protecting your supply chain, about your cybersecurity, because we've seen, again, with the Ukraine conflict, we have seen private sector space assets, as targets. So it's not just, it's only military satellites. It's, everyone could be a potential target. So, so for me, if you're going into the space industry, just being able to have an appreciation of space sustainability, the importance of it, and an understanding of it, so that when you're going to work there and you're asking, the chief engineer or whoever, this is a great place to work, but what are we going to do about space sustainability? Just ask the question, because that's going to get people thinking. So just promote it and be really positive about it, and look at ways that you can ensure that whatever company you go and work for is doing the right thing.
Nice, yeah, I'll be sure to do that. So the next question is from Ariane. She says, well, it's a great talk, and they are glad that this sort of thing is being brought up to avoid greater disasters. They'd like to know if artificial intelligence is being included as part of the technical solutions to predict accurate data, while also providing real-time information as the data is being provided.
Absolutely. I think everyone's looking at how it can help. Again, it's part of the solution rather than being the whole solution. So I think that, certainly a lot of the companies that I know who are working in this area are looking at how to employ AI, but in a way that, actually not just for the sake of it, but in a way that's going to have a real impact on our understanding of that data, and how it can be used. And again, it's, there are some areas where I think AI is the benefits of it could be absolutely huge, but when you start to then go down that route of intent and attribution, some of those areas more within the space domain awareness with the defense side, like all those things, how much do you want AI to be making decisions that could lead to a retaliation or response in some way. And so I think that really good for the data, the analysis, but there's still, like, I think with everything with AI, questions about decision making, even when it comes down to there are two satellites that may collide, who moves? Because that's always a question, who moves, because no one wants to move. You use fuel, it has an impact on your mission and your lifespan. So I think a lot of, there could be quite a bit of nervousness into how far AI is going to play in terms of some of that decision making.
So we're getting down to the last couple of questions. We have one from David asking, what is your opinion on the AST space mobile plan for a constellation of Blue Walker 3 satellites, in brackets 64 square meter antenna?
I'm not that familiar with it, but 64 square meters is pretty big. I'd have to look into it. I'm not particularly concerned with any mission until I've seen what it's going to do in terms of sustainability. I mean, that's, because you could have a constellation of 10,000 satellites, but if that company is doing, really good work to ensure it's mitigating, anything bad happening, great. But if you've got 100 satellites going up and they haven't done anything, that's what I'm going to be concerned about. So, and again, with size. So I think that, that's, I don't know all the details of that one. So I'm going to have a look, see if I can find out.
Cool. That's great. And then we've got the final sort of two questions. So do you see any way around avoiding politics on the ground affecting solutions in space? And then finally, just to finish off, if you could give a little talk, well, some more information about Frazer-Nash and how undergraduate students could get involved with the work that's going on there.
It's really hard to say that politics on the ground, that we can kind of figure out a way around that, because I suppose the best way is almost to take a slightly, I don't even know the right word I'm looking for. Inspirational, that's not quite right. But almost, kind of thinking beyond us, this is so big and it affects everyone. And what we learn from space through, going to the moon, going to Mars, solar system exploration, the James Webb Space Telescope has gone so far out and it's just teaching us so much. It's so much bigger than politics, so much bigger than that. That's why we need to keep space, for good, because of all this. I guess I've just been in this world for long enough and sat through enough meetings and witnessed enough meetings at the UN and at various other places. I guess I'm just a bit cynical about that. I'm just going to give you a little example. I was in Geneva at the UN, and I was sitting in a session, just observing a session on the conference on disarmament, and Venezuela had just taken over presidency, and so the US delegation walked out before it started because they didn't recognize the Venezuelan delegation because of the elections in Venezuela. So straight away you've lost one of the most important actors. Yeah, I'm just too cynical. I would love, if anyone's got any ideas about how to get around Earth politics, let me know, because that'd be great. Yeah, but I'm not hopeful. In terms of Frazer-Nash is a systems engineering technology consultancy. We are about 1,000 strong across the UK and in Australia. We work across many sectors, energy, so everything from sort of decommissioning of nuclear power plants, wind turbines. We do rail infrastructure. We do work for civil government, lots of industry. I work in the defence area, so we do a huge amount of support across all domains. The kind of work we do, it would take hours to kind of go through everything that we do, but it could be a safety case for a part of a submarine. It could be some digital assurance for some software. It could be more sort of strategic advisory. We do a lot of work on data modeling, analytics, AI, electrical engineering. Essentially what we do is we like to solve really complex problems. So, what we do is we help our customers who, come and go, we have a problem, how can you help? Space is a fairly new area for us. So my colleague James and I took over the space sector in May last year. James looks after our sort of civil space, solar power and European Space Agency work, and I do all the policy and defence work. It's a really exciting time. I mean, in terms of Frazer-Nash, we have a graduate program, so check out the website because there's always interesting work there. We have summer placements. As a company, it's great because you can work in one sector, or you can work across many areas. So you'll sit in a group. Thanks, Ian. Yeah, check that out there. And you could be spending 2 days a week, working on a project that supports the Navy, and then 2 days a week on something to do with wind turbines. I mean, it's great to work in that area because I think it exposes you, the difference between, I suppose, consultancy and a company that sort of produces something is the range of what you could be doing. So rather than just going in as, I am an engineer in this area and I'm just going to spend the next 10 years perhaps working on sort of one project, come to Frazer-Nash and you'll be doing a bit of bid management, you're writing bids, you can help, you can get involved in, with business managers like me on campaigning and working with customers. So definitely check it out. In terms of space, yeah, we've got a lot of really exciting work coming up. Space solar power is a huge area for us that my colleague James looks after. Potentially a lot of work coming there, looking at what is the real potential of space solar power and how can we support that. To we're looking at supporting Space Command and DSTL on a lot of the sort of military space programs. So have a look at that. Space as a whole, I'll wrap up very shortly. Space as a whole in the UK is growing and we need more people. So this is definitely the right industry to be getting into. But there's a skills shortage. So, the more of you that we have coming out is going to be better. And there's just so many exciting opportunities going forward.
Cool. Thank you very much for answering all those questions so well. So we've got the Frazer-Nash careers link in the chat. I've also put in the Sun YouTube channel, so all of these sessions are recorded and they'll be uploaded there. And we've also got a small feedback poll which I'll just launch now. But apart from that, that's pretty much everything. And I'd just like to say a big thank you to Ali for such a great talk and handling all of those questions as well.
Yeah, thanks so much for the invitation. Really enjoyed it.
Thanks, Ali, and thanks to everyone for joining us this evening on this webinar. And hopefully we'll see you for our future webinars. If you keep an eye on your local channels, we try and get out to as many people as possible through the university's network.